In the vast tapestry of life on our planet, there are worlds hidden in plain sight, teeming with creatures of extraordinary complexity and at times extraordinary danger. I invite you now to join me on a journey, not across sweeping savannas or into the darkest depths of the ocean, but into the miniature realm of insects. Here, amongst the blades of grass and within the shadows of our own homes, live some of the most formidable assassins in the natural world. They are small, often overlooked, but their impact on life, including our own, is immeasurable and profound. These tiny beings, with their intricate exoskeletons and multifaceted eyes, wield arsenals that can rival any of the great predators. Their venoms, their methods of transmission, and their sheer adaptability make them far more dangerous than their size would ever suggest. A single sting, a silent bite, can unleash a cascade of biological warfare, turning a peaceful afternoon into a fight for survival. We see them, but we rarely understand the true power they hold. A power honed over millions of years of evolution in a constant battle for existence. Yet, for all that we have learned through painstaking observation and scientific endeavor, so much remains shrouded in mystery. How can a creature so small inflict such monumental pain? How do they constantly outwit our best efforts to control them? These are not just academic questions. They are puzzles that hold the key to understanding life, death, and the delicate, often perilous balance of our shared world. Some of these mysteries, as we shall see, remain tantalizingly unsolved, reminding us of how much we still have to learn. Deep within the humid rainforests of Central and South America, a formidable hunter patrols the forest floor. This is the bullet ant, Paraponera clavata. It is a creature of remarkable size for an ant, nearly an inch long, and it moves with a deliberate, almost menacing confidence. It is not its size, however, that has earned it a place in local legend and scientific notoriety. It is the power contained within its sting, a weapon so potent it is said to feel like being shot with a bullet. A searing, throbbing, all-consuming agony that can last for a full 24 hours. The sheer intensity of this pain is almost unparalleled in the insect kingdom. Indigenous peoples have famously used these stings in brutal initiation rites, a testament to their devastating effect. The venom is a complex cocktail of neurotoxins, chief among them a peptide called toxin. This toxin targets the victim's central nervous system, blocking synaptic transmission and causing uncontrollable, excruciating pain signals to fire relentlessly. It is a defense mechanism of shocking efficiency, a clear and unforgettable warning to any predator foolish enough to disturb it. But here lies a profound mystery. While we have identified the primary agent of pain, the full composition of the venom and the precise way its many components interact to create such a unique and long-lasting agony remains poorly understood. Why did this one species evolve a defense so disproportionately powerful? What intricate evolutionary pressures sculpted this specific neurotoxin to be so exquisitely effective at causing pure, unadulterated pain? The ant guards its secrets as fiercely as it guards its nest, leaving us to marvel at the chemical mastery of this tiny yet terrifying rainforest warrior. It is perhaps the most familiar insect on Earth, its high-pitched whine the soundtrack to countless summer evenings. The mosquito. While most encounters result in little more than an irritating itch, this seemingly insignificant creature is, by a staggering margin, the deadliest animal on the planet. It is not a predator in the traditional sense. It does not kill for food directly. Instead, the female mosquito is a vector, a biological hypodermic needle that transmits a horrifying array of pathogens from one host to another as she seeks the blood meal needed for her eggs. Malaria, dengue fever, Zika, West Nile virus, the list of diseases for which the mosquito acts as a courier is long and terrifying. Each year, hundreds of thousands of people, many of them children, succumb to these illnesses. The mosquito's proboscis, a marvel of biological engineering, pierces the skin so delicately that its intrusion is often unfelt. In that moment of silent trespass, it can inject saliva containing anticoagulants, and with it, the microscopic agents of death that have plagued humanity for millennia. It is a silent global pandemic delivered on gossamer wings. The enduring mystery of the mosquito is its breathtaking adaptability. For every new insecticide we develop, resistant populations seem to emerge with astonishing speed. They alter their behavior, changing their biting times and locations to evade our defenses. How does their genetic code allow for such rapid evolution? How do they so effectively locate their hosts, sensing our carbon dioxide, our body heat, and our unique chemical signatures from great distances? Unraveling the secrets of their resilience is one of the most urgent quests in modern medicine, a race against a tiny, adaptable killer that continues to outmaneuver us. In the world of insects, there are really few names as aptly descriptive as the assassin bug. This is a diverse family with over 7,000 species, and these predators are masters of ambush and lethal precision. They're equipped with a sharp, curved proboscis, or rostrum, which they use not for sipping nectar, but for stabbing their prey. Once impaled, the bug injects a potent enzyme-rich saliva that, well, liquefies the victim's internal organs from the inside out. The assassin then simply sucks out the resulting nutrient-rich slurry, leaving behind just a hollowed-out husk. Their hunting techniques are honestly a source of constant fascination and study. Some species are masters of camouflage, blending perfectly with bark or flowers, and waiting motionless for an unsuspecting victim to wander a little too close. Others are more cunning still. Certain species have even been observed coating their legs with sticky plant resin to better grip their prey. It's a clear example of tool use. Perhaps most macabre are those that wear the corpses of their previous victims, creating a grotesque camouflage that both hides them and perhaps lures in other insects. The enigma of the assassin bug lies in the complexity and variation of these behaviors. How did such sophisticated hunting strategies evolve across so many different species? The precise chemical breakdown of their venomous saliva, which can be both paralytic and digestive, varies immensely and honestly is still not fully catalogued. And the mystery of their corpse-carrying behavior remains debated. Is it purely for camouflage, a chemical lure, or something else entirely? These silent, patient hunters remind us that in nature, the line between ingenuity and terror is often incredibly fine. Across the sun-drenched savannas and woodlands of sub-Saharan Africa flies an insect inextricably linked with the continent's history, the tsetse fly. Larger and more robust than a common housefly, it's a creature that has shaped human settlement and agricultural patterns for centuries. Both males and females are obligate blood feeders, armed with a formidable proboscis that can pierce even the thick hide of a buffalo. Their bite is painful, but honestly, the immediate discomfort is the least of the dangers they pose. The tsetse is the sole vector for a group of parasites called trypanosomes. When a tsetse fly bites an infected host, it ingests these microscopic parasites. They multiply within the fly's gut before migrating to its salivary glands, ready to be injected into the next victim. In humans, this causes African trypanosomiasis, or sleeping sickness, a devastating neurological disease. The early stages involve fever and headaches, but as the parasites cross the blood-brain barrier, the symptoms become truly terrifying. Confusion, personality changes, and a disruption of the sleep cycle that gives the disease its name, eventually leading to coma and death if left untreated. One of the great puzzles surrounding the tsetse fly is its unique life cycle. Unlike most insects that lay hundreds of eggs, the female tsetse produces a single larva at a time, which she nourishes within her own body, almost like a mammal. She deposits this fully grown larva in soft soil, where it immediately burrows and pupates. This low reproductive rate is really unusual for an insect, and how it sustains their populations, especially in the face of control efforts, is a subject of intense research. Understanding this strange, mammalian-like reproductive strategy may actually hold the key to finally breaking the cycle of this ancient and terrible disease. Under the cover of darkness, while we're at our most vulnerable, another silent threat emerges. It's known by an almost romantic name, the kissing bug. A member of the assassin bug family, this insect, found primarily in the Americas, is drawn to the carbon dioxide we exhale as we sleep. It typically bites its unsuspecting victim on the face, often near the lips or eyes, and that's where its deceptive name comes from. The bite itself is often painless, so, the sleeper is rarely disturbed. The true danger comes not from the bite, but from what happens next. After feeding, the kissing bug often defecates on the host's skin. Within its feces are the protozoan parasites, Trypanosoma cruzi. When the sleeping person instinctively scratches the itchy bite, they unwittingly rub the infected feces into the wound or into the mucous membranes of the eye or mouth. This is the gateway for the parasite to enter the bloodstream and begin its insidious work, causing Chagas disease. It's a slow, chronic illness, often asymptomatic for years or even decades, before it manifests as severe, life-threatening heart and digestive problems. The unsolved questions surrounding the kissing bug are, honestly, deeply troubling. As human populations expand and climates change, the geographic range of these insects seems to be spreading, bringing Chagas disease to areas where it was previously unknown. How are they adapting so successfully to new environments, including modern homes and urban areas? Why do some people infected with T. cruzi remain asymptomatic their entire lives, while others develop fatal complications? The silent nocturnal habits of this bug make it incredibly difficult to study, and its treacherous kiss leaves behind a legacy of disease and lingering scientific uncertainty. Our journey into the miniature world of these deadly insects reveals a profound and honestly often unsettling truth. Life in all its forms is locked in a relentless struggle for survival, and on this microscopic battlefield, the weapons are venoms, parasites, and incredible ruthless ingenuity. The bullet ant, the mosquito, the assassin, the tsetse, and the kissing bug are not evil. They're merely masters of their craft, honed by millions of years of evolution to be perfectly and terrifyingly effective. They're a stark reminder that size is no measure of power in the natural world. We must, therefore, afford them a certain respect, not of admiration but of caution. Understanding their behaviors, their life cycles, and the mysteries they still hold is not just an academic pursuit. It's essential for our own health and survival. By learning their secrets, we can better protect ourselves and find a way to coexist on this crowded planet, mitigating the danger they pose without destroying the intricate ecosystems of which they are a vital part. These tiny killers demand our attention and our humility, for they have much to teach us about the fragility of life. The world of insects is all around us, and each encounter holds a story. We've explored some of the most dangerous, but countless other tales are waiting to be told. What are your own experiences with the insect world? Have you had a memorable or perhaps unnerving encounter with one of nature's tiny architects or assassins? Please share your stories and observations in the comments below. Let us continue this exploration together, because the more we share, the more we understand the complex and beautiful world we all inhabit.